Hi, Math Champions. Today we're going to learn about basics of algebra. Let's say you came out from your current school and you are joining another school. Okay, when you're joining another school, what's the first thing that you will have to do? You will have to know the names of your classmates, right? Names of your classmates, and then later on you will have to know which students are they are groups, like who is grouped with others, who is friends, who are friends within, like in the existing friends, so that you can decide whom you can mingle with, or whom you want to continue your friendship, make friendship and continue your friendships. You'll also get to know some rules of the school classroom. All those things you'll get to know, right? So this is the basic thing that you have to do when you're joining a new school, right? Similarly, when you are learning something, algebra, first few things that you have to know is, first, different names. Okay. And then what kind of groups are there? Who are friends? Who are enemies? That kind of information. And what are the rules in algebra? All these kind of things is what you're going to learn. That is what I call as basics of algebra. Now you've got a context why we are learning about all these things. Because when you start anything, you have to know the names first. And then you have to know the relationships between those people, those things and everything. Then you have to know how they interact with each other, the rules and everything. Right? So that's the same thing that we're going to do here. Okay. Now, in the previous video, you learned about what is algebra, why it came into existence, and how we are converting a situation or a sentence into algebraic expression and all those things, right? Now, we are going to learn some basic information about algebra. In the previous video, we would have learned, we would have seen there where I'm using X, B, and A, and things like that, T, and those kind of things, right? And I had also explained to you that these are called variables. Why? Because can change in value. They can change in value. Means you can say x is equal to 100 also, x is equal to 1 also, x is equal to 1 by 10 also. It can be x, this value can be anything. So varying in value, that's why it's called as a variable. And why we use alphabets? Because alphabets can take up any name, right? Just like a person is there. A person is there. Uh, if he likes, he can be called Raj also. If he wants, he can be called as Raju also. Or if Viraj also. Like, but it's the same person. It's the same person. Say, for example, his grandfather calls him Raj, and his friends call him Raju. But actual name, his actual name that parents have kept is Viraj. Okay, so I'm just saying that this person is same, but they can have different names, right? This different names. Similarly, x is a variable which can have different values. Okay, that's the meaning. When I say x and use in the same problem, if I'm using another x, that means this x is same as this x. You remember that. If say number of roses is there, number of sunflowers are there. Okay, number of sunflowers are there. If you are giving number of roses, something that you don't know, if you're giving the name for this is R, okay, so that R means stands for roses, you cannot give R as number for sunflowers also, because it might be same, it might not be same. When a particular thing is given, like R means the definition is number of roses. It cannot mean number of sunflowers. That's not possible. So when you're using variables, you have to know that they represent something which is different. So number of roses, and S, for S, you can keep a name S for number of sunflowers. Now, in a scenario, there's a possibility is there that number of roses is same as number of sunflowers. That is there, possible is there. But we never know it. It is not a surety. Based on the problem, based on the context, R can become equal to S. But what I'm trying to say is, when you are giving alphabet, what is the definition of it? Means R stands for number of roses. S stands for number of sunflowers. That kind of definition, that clarity you should have when you're starting using. Means you should know, okay, this person is the prefect. this person is a person who gets average score. This person is a person who doesn't score well, or this person is a person who is very good in sports. That's how you understand different new classmates, right? So the definitions are very clear. Okay, Viraj is good in sports. Okay, Sanya is good in mathematics. Things like that. So the definition should be correct, should be unique, should be same for the particular context, for particular problem. Okay, that's the first thing. So these x, a, b, all these are called variables. Okay, now but there are some numbers, right? Like 6 or 8 or 12 or whatever number. These are all, they cannot change their value. 6 means 6 only. Number, the value cannot change. That's why these are called constants. These are called constants. Okay. Now, if I am saying 6a, now if I'm 6 and a is together, so is it a constant or is it a variable? Let's analyze and understand this. A is a variable, 6 is a constant. Now 6a, if I join together, I'm not adding them, it's a 6a. What is the meaning of 6a? Okay, what's the meaning of 6a? What 6a means, see, this is 1a, there's another A, there's another A, there's another A. So this A means only one A, right? A means, let's say, apples. Okay, apples. 6 apples means one apple here, another apple here, another apple here, another apple, another apple, another apple, right? So the 6 apples. Understand like that. So 6 apples. Okay. So let's say A is the value for, A is the variable for no, the cost of one apple. Okay, I'm going to define this thing. A is the cost of one apple. Cost of one apple. Okay, cost of one apple. Now, what happens to the 6a? Is it a variable or not? Now, cost of one apple is a variable surely, because in one shop, you will get the apple at one apple at 50 rupees. In another shop, you might get it at 25 rupees. The same one apple you can get. If that's the case, let's say two scenarios, I'm taking two, shop one and shop two. What happens to the cost of 6 apples? 6a means cost of 6 apples. No, like 1a, 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 like that. And 6 A's are there, 6 apples are there, 6 apples. 6 apples is short form as 6a. Okay, now cost of 6 apples, what happens to them? Think and see. If one apple is 50 rupees, then the 6 apples will be 300 rupees, right? If one apple is 25 rupees, then 6 apples is going to be 150 rupees. Oh, now you see, in this, the value of 6a is also varying based on which shop we are going to. That means this is also a variable. This is not a constant. The combined 6a is also a variable. So you cannot say when a variable is there along with a number, okay, like this 6a or minus 3y, okay, or 6z or something like that. This is not a constant. This is not a constant. Okay, these are all variable, because if z will vary, then 6z also is going to vary. It's going to change. So it's not a constant. Remember that. But if it is separate, like 100, this is a constant. There is no ambiguity. This value is not at all going to change. So this is a constant. Clear about this? Okay. Now next, let's talk about now this like x is there. Okay, just this x, or let's say 6z is there. Okay, 6z is there, or half t is there. Okay, such things, such things are called as terms. These are called terms. Okay, so why it is like that? It's the name they've given. Means this is one thing. This one particular aspect, one particular aspect, one particular aspect. Let's say. Okay, means let me give you a scenario. Like, so for example, they're constructing a building. They're constructing a building. Okay, and for building, this is like labor charge. Let's say labor charge. This is like 6Z is means for one floor, the materials cost is Z. Then for 6 floors of building that they're going to build, so the material cost, let's say this is. Okay. And let's say this other one is the engineer's cost, like the salary for the engineer who's going to build that thing. Let's say. Okay. So all three things are talking about three different things. Three different things. However, now if I can, like, if I want to know all the total expense of it, then I will say zx plus 6z plus half t, right? My total expense is going to be x plus 6z plus half t. In such a situation, what happens? What happens? This entire thing, this is called as an expression. That means what? Expression can have just one term also it can have. Like for example, like some other thing like 40A. Okay, this is a term as well as it is an expression also. Or the expression could be like this also, addition of multiple things. If you ask me, will it always have alphabets only? No, you can have x plus 2. This is also an expression. Basically, this expression is having two terms. This is one term here. This is another term here. This is having two terms. And in these two terms, one is a variable, that is the x is a variable, and one is a constant, that is 2. So this variable is x and the constant is a 2. I hope you're understanding the difference or connection between various different things. Okay. So many different terms join together to form an expression. If you see in the previous video, you would have seen that when I say sum of x and 2, sum of x and 2, you would have written this as sum of x and 2. So this x is a term, the 2 is a term, this entire thing is a expression. So we had written, we had made these sentences as expressions. Now we say, if we say sum of x and 2 is 8. If I write like this, how will I write this? Sum means plus of x and 2. X and 2 is means equals 8. Okay. Now this became an equation now. That means this was an expression true. Okay. This is also an expression. This expression has having only one constant. Now, however, because it is an equal to sign, this entire thing is called as an equation. It is no more just an expression. It's an equation. Or if we say x plus 2 is greater than 8, then this is called as an inequation. That means inequality. Inequality, this is inequality or inequation, we'll say. Right? Understood? So this is an expression. X plus 2 is an expression. 8 is also an expression. But this 8 does not have a variable. It is only a constant. Okay? 8 is also a term. X is a term. 2 is a term. 8 is a term. X plus 2 together is called as an expression. 8 is an expression as well. But when one expression is equal to another expression, then this entire thing becomes a equation. Equation because it has an equal to sign. So you've understood the various concepts or various different names, right? Now let's see who are the friends, who are the not friends and things like that. So let's say there are different terms here. 6A is there, 7B is there. Okay, these are all terms. Whatever boxes I'm going to put, these are all terms, right? 16C is there, something like that. Okay, or 70B is there. 24A is there. 11C is there. Okay, these are all different terms now. Who are friends? Who are not friends? Okay, friends means who all could be friends? If you see here, 6A term, okay, and a 24A, they are friends with each other. 7B and a 70B, these two are friends. 16C and 11C, these two are friends. Why I'm saying like that? because they're having the same variable. Everything about the variable is same. You can talk like, even you can say 6 apples and 24 apples. Let's say one basket has 6 apples, another basket has 24 apples. Now you can put them all together also, right? They're all of the same category, right? Let's say 7 balls and 70 balls are there. So they're all same category. You can put it all together. So whatever you can put together, right? They are called friends because the variables are exactly same. Such things are called like terms. Means 6a and 24a are called like terms. 6a is a term, 24a is a term. They call like terms, and 7b is a term, 27. These are also called, this together is called as a like term. What is unlike term? Unlike term are things which are not same. For example, 6a, 6 apples and 7 balls. Is there any similarity between those two categories? No. These two form like they are unlike terms. They are unlike terms. They're not same category. Okay. Now, when I say like terms, I can always add them. Right. Now let's take another example and let me ask you whether you are able to figure out whether they're like term or not. Let's say 7a and 24a square. Are they like terms or not? Pause the video, think about the answer, and then see whether my explanation matches your answer. Okay. Before I come up with saying whether they are like terms or not, what I'm going to do is I'm going to assume something, right? Means A has a value. Let's say this value is 4. Okay. This value is 4. When A is 4, when A is 4, what happens to this? This becomes 28. Here 24 times A square. Okay, let me see. What is happening? 7 times 4, this is 7 times 16, this is. If A is a 2, then 7 times 2, this is 7 times, so 24 times 2 square it is. 2 square means 2 times 2, 4 it is. Okay. If A is 3, what is happening? 7 times 3, this is. Here it's 24 times 3 times 3 is 9. Okay, look at this. The rule is completely changing. Here, the first set, you just multiply the value of A with a 7. But here, you're not only doing that multiplication with 24, you're also squaring it. That means the rule itself is changing. The rule itself is changing. When the rule itself is changing, they're not same category. They're not same category. That means, though both the terms are having A and A, but here A is only one time, A to the power of 1. But here A is multiplied 2 times. Here A is multiplied with 7, only one time A is multiplied. But here the A is multiplied 2 times. So the entire rule is changing. Therefore, these two are unlike terms, though they're having same alphabet. So it does not depend that it is the alphabet is same. The entirety about the alphabet should be same. Let's say 6PQ is there and 7QP is there. Now, is this like term or not? Okay, is this like term or not? How do we decide this? What is the meaning of this? 6 is multiplied with P multiplied with Q. 7 is multiplied with Q multiplied with P. Now we know that if you multiply P and Q in whichever order, the answer is going to, the rule is same, right? So, though it is swapped, these two are like terms. What I mean to say finally is the terms with their powers should be same. The variables in the terms with their powers should be same. That means P is a variable with the power 1. P is a variable here also with the power 1. Q is a variable with the power 1 and Q is a variable with power 1. And it's not that anything is missing. For example, 6PQ, 7QPR, let's say. Okay, P and P is matching. Q and Q is matching. But then R is one extra variable is there. So this becomes unlike terms. So I hope you are understanding the relationship concept behind what is like terms and unlike terms. Don't go by just the trick. Go by understanding why it is like that. Okay, that's what I'm trying to explain here. Okay, now when it is like terms, you can add them. Like let's say expression is 6a square plus 7b plus 6c. And let's say another expression is there. 3a square plus 7c plus 1b. Okay. Now, how do I add them up? Means whatever is a like term, I have to write that one below the other. 6a square, that means 3a square in the bottom. And 7c means this 7c and 3c only can get added because they are of same category. Okay, 1b here. So that means it's a 1b here. So B and B is of same category. So what happens? My addition answer will be 13C because 6C and 7C, these are like terms and they can be added. And here again, 7B and 1B is the same term. I'm going to add it. And 6A square and 3A square is the same category, same type they are. So it becomes a 9A square. Similarly, how to subtract also. Let's say I'm going to ask you to subtract 4c from 8a minus 11c. This is what I'm asking. From means I know I have to write 8a minus 11c on the top, right? Subtraction sign, and 4c, right? 4c means I will have to write below this. When I do this, what happens? Minus 11 minus 4, right? It becomes a minus 15c. And with the a, there is nothing for me to add or subtract here. So this is like 0. 8a minus 0 is 8a only, right? 8 minus 0 is same 8, right? So just like that. So the answer will be 8a minus 15c. I hope you're understanding how the addition and subtraction of like terms are happening. Okay, I'll talk about more multiplication and division of algebraic terms in the upcoming video. See you in the next video. Until then, bye-bye. I hope you're understanding and learning all of these things. Okay, see you in the next video.